Hello, everyone. For those who don't know me, my name is Besim Yükselen. I'm the third year PhD student here in Pavia in earthquake engineering under the supervision of Dr. Bernardo Comcedero and Professor Pardo Montero. Today, I will be speaking about the work that I have been carrying out for my PhD work, and it is basically called, it is titled as Multi-Objective Optimization for Seismic Retrofitting Decision Making. So, when we first, I need to explain the motivation and the complexity of the problem itself. So imagine we have a building and we want to retrofit this building. So we have two main aspects in this circumstance. So the first one would be the constraints. We are constrained by the physical laws that, and also the code compliance. And then we have the objectives, which are basically driven by the societal needs and the policies or the stakeholders' needs or the priorities. So, yeah, when we have this problem, when we want to deal with that, imagine that we have this building. It has 300 members, and we want to deal with we want to take care of this with local retrofitting. And it has 300 members. Imagine that we have all the details, and it will have a binary question for each member, and it will have to the power of the 300 solutions. So it will be not easy to solve this problem, even just for the compliance. And the visualization of the decision, the design space would look like something like this. So it is okay. It has feasible and infeasible solutions. They are somehow clustered, but also smeared between each other. So imagine that it is only for the constraint part, and now we have the objectives. How are we dealing with that in the case or in usual? There are many ways to do that. But like I will explain three of them. I will just mention three of them, and the first one is multi-criteria decision making. It is based on predefined alternatives, and it has the weightings all coming from the decision maker, and it sorts them based on the scoring and the relative scoring actually. But it is confined with the candidate set, and it is dependent on the decision maker's subjective weighting, basically. And then we have these index-based optimization ones, or single objective optimization. We can aggregate these objectives or variables that we can have and weighted average or cost benefit analysis or whatever index that we prefer. Then we do the optimization or the scoring of the solutions. But that would make us to lose the information regarding the Pareto, the trade-off between the objectives. So to overcome this issue, there is multi-objective optimization. Can I just mute everyone? How? Sorry. Oh. Right now, watching the video, yeah, is a video, yeah. Sorry, and now I don't know how to fix that thing. Sorry, no, I broke it. Okay, sorry for the interruption. It was because it was disturbing. So anyway, as I said, we have this multi-objective to carry out multi-objective optimization. While we are carrying out it, we can still contain we will search for the Pareto optimal solutions, and we will obtain the trade-off at the end, so the decision maker can do the selection by themselves. And but this has two main considerations. The first one is computationally expensive. because as you see, the design space is huge, and we cannot just randomly start from a point and try to make the framework to find the solution that will be very computationally expensive. And then usually the way to deal with this computational burden is to shrink the solution space uh, by means of clustering the groups, clustering the structural members, or banning some floors, saying that, okay, I'm not going to retrofit more than the second story, and these strategies, but this is not scalable at the end of the day as a framework. So yeah, what I will speak now today to deal with all these considerations, three main points. We are going to see the Cat2Cs tool to make OpenCs more accessible or usable. For the real case buildings, it will use CAD files to generate the OpenCs models and do the assessment, and to carry out the whole optimization, and then it can be connected to the carry out all this optimization process. And then we will see stochastic iterative retrofitting algorithm, which is an algorithm to overcome the issue that I have mentioned, that solution space is very big. We don't want to shrink it, and we want to start in a way that is near or within the feasible space. So then we are going to see the multi-objective optimization results with Pareto optimality that we are still carrying on without losing any information or without mixing any information between the objectives. So, but what is that optimization? When I'm saying seismic retrofitting optimization, what do we mean actually? It has discrete variables, yes and no questions. It has discrete variables with different kind of detailings of the retrofitting. And usually objectives are nonlinear and multimodal, and they are expensive to evaluate. So the gradient is not a solution. We don't have a gradient. So we will adopt non-gradient, gradient-free multi-objective optimization algorithm, which is NSGA2. Non-dominated sorting genetic algorithm is a variant of the genetic algorithm. It starts with selection of the initial set and does the optimization, then we have the final designs. So again, as I say, solution space is very big. We have a computational trouble. So we need to start this procedure in a way that is feasible, that is our first candidates are feasible, then they are going to be optimized. So to do that, we went back to the engineering practice and thought how an engineer will behave when they are trying to retrofit a building. The most straightforward way will be the iterative retrofitting algorithm, which is going to start with the initiation of the model and checking the model, do the assessment. If we find the failing members, retrofit all of them and do the assessment again and check it again and do the loop until you reach the end. You have the retrofitted building, which is code compliant, but this whole procedure is deterministic. You have only one result at the end, and it is deterministic. So, and it is not the way that engineers will do, actually. It's not the reality. Engineers will not directly retrofit all the failing members. They will select some of them. They will not retrofit some of them, but this is based on also engineering judgment, intuition, basic geometrical topological rules, and these many stuff. But again, this is again a building specific problem. If you want to generalize this and scale this problem, we cannot deal with this epistemic uncertainty in an algorithmic way. So what we are proposing is called stochastic iterative retrofitting algorithm. We are transferring the uncertainty of the epistemic uncertainty to aleatoric uncertainty by defining a p-value, which is the probability of intervening a failing member. And we do the assessment. And again, we check the building. If it is, and we visit every failing member, and we generate a number between 0 and 1. If that value is lower than the p-value, we apply the retrofitting. If no, we pass the next one. We do the inner circle. We finish all the failing members, and then we do the assessment again, and we at the end we got the results. The things that you are seeing at the right hand side, these matrices are different solution matrices, decision variables. So that will end up with that is being seen, that we are able to end up with different solutions. So now, if I have an algorithm which is able to produce different feasible solutions, now I can feed my optimization with these initial set to carry out the optimization and find the optimal solutions. So how am I going to integrate them? Is basically we first, again, we will carry 100 Sira independently. We will get the feasible solutions that we get at the end, and then we will integrate it to the NSGA2. It is a very well-known procedure. Actually, it starts with the evaluation of the procedure, non-dominated sorting, selection of the parents, doing the crossover and the mutation, and the next generation is being evaluated and it returns. And until determination criteria met, we continue to the procedure. In this study, we just selected the number of generations to be 50 and 50 as a termination criteria. So we have 50 generations with 100 individuals in the population. So 5,000 different buildings are being assessed and checked based on the objectives. And then we have the final designs at the end as a Pareto front. So to do that, we have a case study. It is located in Lisbon, Benfica. It is from 66 and it has 200 meters square floor plan area. It has 6 stories. It has some discontinuities within the plan, and has 16 different beams, 8 different columns, and the details of the columns are changing in every each story. So this is an easy building, okay? But if you want to scale this, and if you want to model, all of us, I mean, most of us used OpenSys and try to build the OpenSys model without any user interface. So it is a hard job. And it is vulnerable to errors, and it is very hard to see where is your error. So we developed that tool called Get2Sys. It needs only 3 input files, 3D drawings of the building, 3D drawing of the building that you will do it in AutoCAD or FreeCAD or which CAD tool that you want, and the sectional drawings, and then also the general information JSON file. So that will take the tool itself will take all the information, fetch all the information from the CAD drawings, and will generate the model and do the assessment for you based on the Eurocode, based on the also non-structured static non-linear static procedures. So also we have the visualization module of it, so we can see, are we really modeling the thing or not? You can reach it from the QR code. It is available on GitHub. If you have any doubts about it, please, please, it will be very good. So we have assessed the building. This building has a shear failure, basically. We have assessed 2 scenarios in here. The basic, the S-build and the basic intervention to just introducing a seismic gap between the infills and the surrounding frame. Although it is a good intervention, I mean, it is somehow saving something from the building, but it's still not code compliant, so we need to retrofit the building. We have employed steel jacketing with 3 different angle sections, 3 different batten sections, 7 different spacings, in total 63 different combinations that can happen. and also for each member, yes or no question. So the design space is big at the end. So as an objective, regardless of the constraint of being code compliant, we have decided on 6 objectives and grouped them into 2: investment-oriented and the performance-oriented objectives. The investment-oriented objectives comes with due to the installation of the retrofitting, installation cost, and the installation environmental impact. And we are calculating them as follows: like we identify the bill of quantities for each retrofitting scenario, and then we multiply the unit prices or unit carbon emission, and then we sum all of them and get the total cost or total environmental impact. On the other hand, when we go to the performance-oriented objectives, we have the expected annual losses, expected environmental impact, and the non-structural loss ratio. So how we are doing it? Now, I just want to remind you that we are dealing with 10,000, 5,000 building, right? So we should be careful in here. So what we are doing, we are defining the hazards and selecting the ground motions, ground motion records, and scaling them. We used 15 intensity measure levels, and the structural response comes from the non-structural nonlinear pushover. And we use the capacity spectrum method with the real reports itself. We identify the performance point. At the performance point, we got the drifts. From the drifts, we can get the PFA with the relationship, with the drift-based relationships. So we have the EDPs now. So we can have the collapse fragilities within the performance point also. So we can input all this information to the FEMA P58 procedure. We use Pelican for that because, it's like 5,000 buildings at the same time. So we got the expected annual losses, expected environmental impact, non-structural loss ratio, and also the damage states of the components. Why we are getting the damage states of the components? Because we want to do the downtime assessment. So we got the damage states, and we collected the repair consequences from the literature. We employed the procedure, the code from Molina Hart et al., the threads, and we aimed for the reoccupancy for the building because this is a residential building, and we got the expected annual downtime. Because we did for each intensity measure that we have. So I spoke a lot, what I said actually, and what are you going to see. The procedure, as you see, it starts with the selection of the initial set. It uses the get to Cs to generate the building, and it uses the CERA to generate the initial set, and then it does the optimization with 6 different objectives, and we will have this final, the final designs now. I will show you. This is the CERA results shown in 2D space. Although, first of all, I should mention that every result that you are seeing in these plots after now would be Pareto optimized. So they are theoretically equal. So in this plot, what you are seeing, basically, the Pareto fronts in 2D space, when I'm comparing 2 objectives, although I have done the optimization on 6 dimension, I have it in 2-dimensional space, the pairwise speed. If I move to the NSGA tool in the optimization, we can see that NSGA optimization is exploring more while carrying out the CERA results that we have obtained. So now it will be the harder plot. This is 6-dimensional problem. To visualize it, that thing that you are seeing is parallel coordinate plot. And it follows every axis that you see, another objective that we are employing. And every line that you are seeing is a point in six-dimensional space, basically. So you are seeing the serial results now, and as you can see, it is able to minimize the cost and environmental impact, but it is compact, and it is compact and clustered. And when we employed NSJ2 on the all of them are on the Pareto optimal on the Pareto front, we can see NSJ2 explores wider region in the objectives, and we can see that between the investment-oriented objectives, there is a harmony. And similarly, in the expected annual losses, expected downtime, and expected environmental impact, we have that harmony. But of course, we have the trade-off between the cost and the investment and the performance. And interestingly, we have the trade-off between the performance and the non-structural loss ratio. So when that is a hard to grasp plot, I know. So what if I minimize if I get the extreme points in the Pareto optimized? If I minimize the cost and the environmental impact of the installation, Sierra getting something which is the same thing that is which is the same value in that objectives got by the full optimization framework. But optimization framework is able to minimize the losses also. And we can see that they are almost similar. Like the environmental impact and the cost are following a similar trend. So on the other hand, if we would love to minimize downtime, the losses, and the environmental impact due to earthquake, so you have 2 points there. Either you waive the cost, or okay, you have to waive the cost. So it comes with the cost. You have to increase the cost to reach the minimum with Sierra. But NSGA2, when we add the optimization algorithm to the end, it is able to minimize that costs also together with the other performance objectives. But when it comes to the non-structural loss ratio, that is a bit different because it is different to think. You have to think about the fragility function, how it moves. So because this is the ratio. So as I said, you can have different results, and if we move from here to a large-scale assessment, we have this variability within the fragility functions on the yielding and the collapses. If we want to minimize the losses, we can shift the fragility to the right. But if we want to minimize the costs, we will shift the fragilities to the left. So, but which one are we going to use? So we have to consider that in the large-scale assessment. And with that, I will conclude my presentation. What we have seen, Sierra generates, we have seen the Sierra, it generates different retrofitting solutions, evaluate the engineering judgment, and reduce the computational burden. And NSJ refines the solutions, broader exploration of the Pareto front. And of course, the full framework itself is able to define balanced solutions with the balanced solutions on the resilience and economy and the environmental impact and sustainability. And CAT2C is increase the increase the usability of the OpenSeas itself, and of course, approach. Like until now, when I speak, I did not say I will group these beams, I will block this floor. I did not say that, so that we don't need to know about the building when we are applying this procedure or this full framework. So that makes it first practical, second scalable, and also computationally affordable. Okay, it takes time, it is big still, but it is computationally affordable when we think about the full solution, full search space itself. And as the last point, as I mentioned just one slide ago, the retrofitting building fragility has the variability inherently coming from the engineering decision. So we should take care of that one. And with that, I'm finishing. Thank you very much. And I'm ready to answer any questions, if any.
Good questions for Besim. Thanks, Besim. Good work. Was a very interesting report, and I think you did a lot of stuff. So made some notes of how to do it probably. A couple of things to ask. Maybe I didn't misunderstood you, but the last parameter to optimize was the non-structural cost or risk ratio.
Sorry, non-structural loss ratio.
Oh, I'm wondering how come if you improve performance in general of the building, non-structural cost ratio increases?
Okay, that is a very good question. Thank you for the question. It's very on the point. First, this is a ratio. It's not the cost itself. And when we say improving the performance, we are improving the performance of the structure. We don't care about the full building itself. So this is a ratio. At the end of the day, it's a summation of the non-structural losses, structural losses, and the losses due to the collapse, right? If I decrease the collapse, the losses due to the collapse, the ratio of the cost, the non-structural loss, although it stays same or decreases, will get higher.
Yeah, got it. Probably from the point of like pushing it towards people using it, maybe as a suggestion, maybe specified, because it seems like it's a bad thing that's happening, but in reality, it's really nothing bad is happening. So it just stays.
Yeah.
The second is maybe another maybe again a suggestion in general, or you can follow or not. But for example, you look at the capital investment, right? It's basically capital first, like original investment, and we see that to keep it optimized throughout the entire scope of metrics. If you increase capital investment, obviously the performance will increase, but you might have other issues like to keep it Pareto optimized, like performance will change. But for example, another thing that could happen in the long term, so this is the capital investment, but in the long term, you might be actually saving money, even if you do a capital big investment. So would it be possible maybe to consider it within the framework in the future, or maybe there is still some wiggle room to change the like to just or it's just in general possible to include this type of optimization as well?
Yeah, as I understood, thank you for the question. As I understood, you are okay. This is the first money that is going to be spent. But the framework itself can work in any objective, right? So you can change the objective. Of course, it is important to also think about in the long term what will happen to the first investment that we are giving. Yeah, indeed, it is important to think about it. But yeah, as I said, this framework itself, it can accept any any objectives.
Yeah, probably it's better than what we see that because it's not. It's still doing an even better job given that the fact that you are optimizing on both areas. Even so, it's not quite visible immediately. It's visible more indirectly. And another thing, sorry, third thing, it's related to the ECA compliance stuff. So in the beginning, you mentioned how the engineers would not be retrofitting every single element in the building that they have. It has been damaged or whatever, which makes sense. But then there's a randomized procedure, right, to do a retrofitting of X amount of elements. So at the end of the procedure, I don't know, maybe I missed it, but I believe maybe you didn't mention that was the building in the end of this randomized selection still ECA compliant or?
Yeah,
probably I missed it.
Yeah, it will be my mistake, to be honest. No, it is. The easy answer is it is.
Yeah.
The first answer it is, but the whole algorithm is here. So you have two for loops, basically. In the first for loop, you are just visiting all the members, right? All the members that are failing. And then you go check the building again. And if it is failing, if it is not code compliant, then you do the same procedure again and again. Of course, the p-value, if we decrease the p-value, it will explore more, but the computational time will increase. Indeed.
Yeah, I think, yeah, you have it there. I just didn't see it in the color box. Cheers.
So, just wanted to add some. Point numbers about David. I think that the point number 2, David was referring to a life cycle metric. So we should, and I think it's something we need to discuss at some point. We should include the estimates of all the costs throughout the entire life or residual life of the building that you still have after the retrofitting. So for sure, that is something including maintenance, but also maintenance referring to degradation. That's a whole new world opens there. So if you have deterioration or degradation, you can adapt your retrofitting to include specific materials that protect your structure more to degradation. So it might cost more, as David was saying, but it will pay off because in the end, the structure will last longer, maintaining its good performance. So for sure, I think these are the metrics that need to be revisited, let's say, from a life cycle perspective. I think this is what David was referring to.
Yeah, I think the word that was coming to mind when David was asking the question was break-even time. It is something that has been used in the past, but not exactly what Ricardo just mentioned, but that kind of metric. I think you plugged out the trajectory again. No, it's fine. Anybody else with a question or comment? Even online, if you have something, just please feel free to chip in. If not, I can ask you in the meantime. When you talked about the non-structural element ratio, the NSE ratio, right? Was that an annualized quantity? So
Yeah.
Okay, it wasn't at a specific, let's say, return period or something.
No, it is the expected.
Yeah, so let's say the expected annual loss, but then the ratio between that.
Yeah.
Okay. And then my other second question is actually related to this specific slide. I may have missed it because I had to step out for a second to get this sheet. But when you have your initial combinations, so you had the slide at the beginning where you said if you have something like n number elements, you have 2 to the power of n possible combinations, which are all of the different let's say variations or simulations you can possibly do. Yes, it was one of the very first things you said. Exactly, the possible schemes. So for a structure like that, you would have 2 to the power of 300 combinations, which isn't exactly a small amount. And then you obviously go through it and do different trials and arrive at possible and optimal solutions. But I'm wondering, do you have any screening in there? So you had a cloud of points, I think, of all the different combinations.
Yeah.
Do you have any screening to exactly that? Of maybe this is answering the question, but feasible and unfeasible, because there may be situations where like concepts like strong column with beam still hold. Like that's not going to go. We're not going to start retrofitting all of the beams and columns as possible combinations. to, the code doesn't allow that. So some, let's say, engineering logic in there so that you can, let's say, sure, there's to the power of 300 combinations there, but maybe half of those are just like silly things that would never ever happen in reality. Do you have any screening process in there to maybe consider logicals?
Thank you. This is like I have been waiting for this question to be asked for this speaker actually. No, easy answer no. But why no? Because because the procedure is aiming to have a irrelated situation from the building. So indeed we can add these solutions we can initiate the SIRA, that procedure that generates the building, generates the feasible buildings, that one that this one. Indeed, we can start as the initial case. We can start with the things that you were proposing. Indeed, it can be a solution, but no, because we didn't do that because we wanted to be sure that without any information we can go from scratch to the end. I mean, to put that would limit the scalability of the work at the end.
It could help you optimize it a little bit, though, because you will avoid trialing and doing analysis on combinations that will never be used. That was my point. It would just maybe help you optimize it further the algorithm you're using.
But okay.
Decision making part, because of how framed it was.
Because otherwise the others won't listen, right? So imagine that you still have a Pareto front made of solutions that were all logical, as you said, right? Or reasonable. I don't know what was the adjective that you used. You still have a decision-making problem afterwards because you might have 20 or 30 solutions, and which one are you going to choose? They are all at the same level because they belong to the Pareto front. And so you have to make a decision. So we will need more tools or more criteria or a framework to then make the final solution if we want to get to that point. And so at that point, I would say that filtering, we can also apply it at that stage, right? So you can rule out the ones that are, let's say, unreasonable from an engineering logical point of view, and then focus your decision on the ones that are left. I don't know. I mean, it's not something that we have yet. I mean, we've started to work on that, but we have no results yet or no proposal. What did you want to ask? Okay.
I'm not sure if anybody is on the line, but maybe if you move the cursor over the chat box, maybe. Okay.
How can I do that?
Over the red and green, it should appear. Yeah, maybe open the chat. Possibly no. No,
it's okay.
Thank you.
Yeah.
Any other question or comment from anybody for this? Okay, so I guess you're free to go. So thanks again.
Thank you.